Section 11.4, percent yield. The objectives of this lesson is to calculate the theoretical yield of a chemical reaction from data and determine the percent yield from a chemical reaction. Some vocabulary to review will be a process, and some new vocabulary you'll come across is theoretical yield, actual yield, and percent yield. While solving stoichiometric problems in this chapter, you might have concluded that chemical reactions always proceed in the laboratory according to the balanced chemical equation and produce the calculated amount of product. This, however, is not the case. This, however, is not the case. Just as you are unlikely to make 100 out of 100 free throws during basketball practice, most reactions never succeed in producing the predicted amount of product. Reactions do not go to completion or yield as expected for a variety of reasons. Liquid reactants and products might adhere to the surfaces of their container or evaporate. In some instances, products other than the intended ones might be formed by competing reactions, thus reducing the yield of the desired product. Or, as shown in Figure 11.8, some amount of any solid product is usually left behind on filter paper or lost in the purification process. Because of these problems, chemists need to know how to gauge the yield of a chemical reaction. In many of these stoichiometric calculations you have performed, you have calculated the amount of product produced from a given amount of reactant. The answer you obtained is the theoretical yield of the reaction. The theoretical yield is the maximum amount of product that can be produced from a given amount of reactant. A chemical reaction rarely produces the theoretical yield of product. A chemist determines the actual yield of a reaction through a careful experiment in which the mass of the product is measured. The actual yield is the amount of product produced when the chemical reaction is carried out in an experiment. Chemists need to know how efficient a reaction is in producing the desired product. One way of measuring efficiency is the means of percent yield. Percent yield of product is the ratio of the actual yield to the theoretical yield expressed as a percent, in which percent yield is actual yield over the theoretical yield and times 100. Let's look at example problem 11.6. Solid silver chromate forms when potassium chromate is added to a solution containing 0.5 grams of silver nitrate. To determine the theoretical yield of silver chromate and calculate the percent yield if the reaction yields 0.455 grams of silver chromate. To analyze this problem, you know the mass of a reactant and the actual yield of the product. Write the balanced chemical equation and calculate the theoretical yield by converting grams of silver nitrate to moles of silver nitrate, and moles of silver nitrate to moles of silver chromate, and moles of silver chromate to grams of silver chromate. Calculate the percent yield from the actual yield and the theoretical yield. What we do know is the mass of silver nitrate, and we know that we actually yielded 0.455 grams of silver chromate. But what we don't know is the theoretical yield of silver chromate, and we don't know the percent yield of silver chromate. So what we need to do is we're going to take that chemical, we're going to take our reactants and create our products. This looks like a double replacement reaction, and we're going to go ahead and balance that out. Once we go ahead and balance that out, again, we could use the stoichiometry of our known mass of silver nitrate, convert that to moles of silver nitrate, take those moles of silver nitrate and convert them to moles of silver chromate, and then once we have those moles of silver chromate, we can turn that into a mass of silver chromate. So our theoretical yield of this reaction tells us that we're going to go ahead and have 0.488 grams of silver chromate. However, we only recovered 0.455 grams of silver chromate, which is telling us that we had a 93.2% yield of silver chromate in this reaction. At this point, how about we go ahead and pause the video and try practice problem number 29. Here is your answers to practice problem 29. Percent yield is important in the cost effectiveness of many industrial manufacturing processes. For example, the sulfur shown in figure 11.9 is used to make sulfuric acid. Sulfuric acid is an important chemical because it is a raw material used in many products such as fertilizers, detergents, pigments, and textiles. The cost of sulfuric acid affects the cost of many of the consumer items you use every day. The first two steps in the manufacturing are shown below. And in the final step, sulfur trioxide combines with water to produce sulfuric acid. The first step, the combustion of sulfur, produces almost 100% yield. The second step also produces a high yield if a catalyst is used at a relatively low temperature of 400 degrees Celsius. A catalyst is a substance that speeds up a reaction but does not appear in the chemical equation. Under these conditions, the reaction is slow. Raising the temperature increases the reaction rate but decreases the yield. To maximize yield and minimize time in the second step, engineers have devised a system in which the reactants, oxygen and sulfur dioxide, are passed over a catalyst at 400 degrees Celsius. Because the reaction releases a great deal of heat, the temperature gradually increases with an accompanying decrease in yield. Thus, the temperature reaches approximately 600 degrees Celsius. The mixture is cooled and then passed over the catalyst again. A total of 4 passes over the catalyst with a cooling between passes results in a yield greater than 98%. Section 11.4 Summary. The theoretical yield of a chemical reaction is a maximum amount of a product that can be produced from a given amount of a reactant. Theoretical yield is calculated from the balanced chemical equation. The actual yield is the amount of product produced. Actual yield must be obtained through experimentation. Percent yield is the ratio of actual yield to theoretical yield expressed as a percent. High percent yield is important in reducing the cost of every product produced through chemical processes.